So today we're going to start section 2 from chapter 4. We probably will not get through all of the examples, but we'll see how far we can get. Whatever I do not finish today, I will finish tomorrow. I am going to post a completed video on YouTube of all the examples worked out. So today we're going to graph the rational functions. So these are the steps that we need to follow. So we're going to use the information that we learned in section 1. We're going to be finding the asymptotes. We're going to find out if there's any holes by simplifying first. And then from there, we'll find our x-intercepts and our y-intercepts. And then we'll plot additional points to create our graph. So these are the steps that we'll follow. And again, the homework is a PDF. However, I don't want to see just the graphs. I want to see all of the work that it's going to take to get to the pieces of the graph. So just like I'm going to show you today, this is also what I want to see on the PDF homework. So let's go ahead and take a look at our first example. So I'm going to do just like I did in the 4-1 homework. I'm going to look for my horizontal asymptote first. So my horizontal asymptote, remember we have to look at the degrees. So the degree of my numerator is 0. It's a constant. The degree of my denominator is a degree of 1. Remember, when the top degree is the smaller degree, then we know automatically my horizontal asymptote is going to be the x-axis, and it's going to be y equals 0. So when I go to graph this, it's going to be the x-axis. I'm going to highlight it. So this is the first piece of information that I found. When I go to put it on my graph, I'm going to highlight it in green. My next piece of information that I need to find is my vertical asymptote. So to find the vertical asymptote, remember we set the denominator equal to 0. This is how we find it. So my denominator is x minus 2. I set it equal to 0. I'll add 2, and I have a vertical asymptote at x equals 2. And again, this is a vertical line, and the equation for that vertical line is x equals 2. Now, my first step should have been to simplify. I did not need to simplify this, so it was already in simplest form, so that's why I went right to step 2, which was to find the asymptotes. Step 3 is to find the zeros, which are the x-intercepts. So I'm going to be finding the x-intercepts. To find an x-intercept, remember you set y equal to 0. Remember, g of x, this function notation is just a fancy way of saying y equals. So I'm going to take my function, the g of x equals 3 over x minus 2. I'm going to replace g of x, which is really y, with a 0. And I'm going to solve for x. Now, essentially, bottom line here, shortcut is to find an x-intercept, all we have to do is set the numerator equal to 0. But let's go ahead and do the whole process of setting y equal to 0. I'm going to solve for x by getting this x minus 2 out of the bottom of the fraction. But notice when I do that, it cancels from here. But then on this left side, anything times 0 just gives me 0. Now, if there were a variable in the numerator, I would have something to solve. But this is not a true statement, so this tells me that there are no x-intercepts when you're left with nonsense to solve. So no x-intercepts. Now let's find the y-intercepts. So for the y-intercepts, we're setting x equal to 0. So I take my function, the g of x, 3 over x minus 2, and now I'm going to take out x and put in a 0. Solve what remains. So 0 minus 2 is negative 2. So my y-intercept is located at the order pair 0, comma, 3 over 2. Now I'm graphing this, so I highly recommend you make this a decimal or a mixed number. So this is actually negative 1.5. So now I'm going to take this information, my x-intercepts, my y-intercepts, my vertical asymptote, and my horizontal, and I'm going to put this information on the graph. Then I'm going to do a table of values to find the additional order pairs. So let me go ahead and make a coordinate plane here. I'm going to draw my y-axis, my x-axis. Add in some markings here for numbers. So your horizontal asymptote, remember, was y equals 0. So it's going to be the x-axis. This is where y equals 0. So that's your horizontal. For my vertical asymptote, remember, it was x equals 2. So that's the vertical line here of x equals 2. This is the vertical asymptote. Let me go ahead and also add in my x-intercept, which was none, and then I'll add in my y-intercept, which is the order pair 0, comma, negative 1.5. So it's located right here. Now, the graphs of these rational functions are going to look like boomerangs. So now I need to figure out, where is my graph located? Is it going to be in this section, in between the two asymptotes? Or is it going to be here? Obviously it's going to be here because I already have a point. Or is the other piece going to be here or here? So the way that I'll figure out where it's going to be located is by doing a table of values. So for example, I'm going to set up and put g of x here, 3 over x minus 2. And now I can pick whatever x's I want, except when x equals 2, because that's the asymptote. I'm going to plug in any x you want to get some more order pairs. So I'm actually going to plug in negative 1, and I'm going to follow order of operations. So 3 over negative 1 minus 2, 3 over negative 3, which gives me negative 1. So now the order pair that I'm going to be graphing is going to be negative 1, negative 1. Let me get another point that's going to be to the left of that blue line. So let me plug in positive 1. Again, you can pick whatever you want. If you want to plug in negative 10 or negative 5, that's up to you, or even a fraction. So these are the two numbers I've plugged in so far. So 3 over negative 1 minus 2 gives me 3 over negative 3, which gives me negative 1. So 1, negative 1 is my next point. Let's see. Did I?
Negative. I think it's supposed to be positive.
Thank you. This should be a positive 1. So then this changes my denominator. Let me fix this. I'm plugging in positive 1. And this is a minus 2. So then this becomes negative 1. So then I get 3 over negative 1, which is negative 3. So I'm going to graph the order pair positive 1, negative 3. Now these are all points that are to the left of my blue asymptote here. So let me go ahead and graph them. So negative 1 is right here. And then positive 1, negative 3 is going to be over here. Now, the graph of these rational functions are going to be like a boomerang. And remember, think of the asymptotes like walls that your graph is going to skim along. So if I go ahead and connect these points, my graph is going to skim along and slowly but surely approach the two asymptotes. It's going to keep getting, as it goes to infinity or negative infinity, it's going to get closer and closer. So that's the first part of the graph. Now I need to pick x values that are to the right of the blue line. So let me plug in positive 3, and I'm also going to plug in positive 5. So let me go ahead and do the math here. So 3 over 3 minus 2. 3 minus 2 is 1, and I get positive 3. So I'm going to graph the order pair 3, comma 3. So now let me plug in 3 over 5 minus 2. 3 over 3, which is 1. So 5, comma 1. So let me graph these two order pairs on my graph. So 3, comma 3. One, 2, 3. And then I'm also going to graph 5, comma 1. And again, it's going to take a boomerang shape. So it's going to sort of skim along here and then come on up here and that is your graph of that rational function. Now let's talk about the domain. Remember, domain are all the x values. You should always think that the domain is all real numbers except when we have fractions. And remember, the only number that would make this undefined is when x equals 2. So that's where our asymptote occurs. So the domain, if you were to write this, and I was going to initially give you WebAssign homework, and in the WebAssign, it would expect you to describe the domain in words. So you would have said the domain is all real numbers except when x equals 2. In interval notation, it would be from negative infinity up to the 2, unioned with 2 to infinity. So this is the domain listed in interval notation. So for number 2, first check to see if you can simplify it. I cannot simplify anything here. If you remember way back when, from the beginning of the year, remember when we simplified rational equations, this is attached. So the only way I could simplify something if there was another 2x minus 1 to simplify with it. And there's not. So nothing can be simplified here. So now I'm going to look for my horizontal asymptote. Remember, for the horizontal asymptote, we're going to look at the degrees. The degrees are the same. So when the degrees are the same, we use coefficients. The coefficient of the numerator is a 2. The coefficient of the denominator is a 1. So my horizontal asymptote is the equation y equals 2. I'm going to graph the horizontal asymptote in green. Now I'm going to find my vertical asymptote. The vertical asymptote, this is where we set the denominator equal to 0. X equals 0. It was that simple. So that's where my vertical asymptote occurs. To find the x-intercept, we're plugging in y equals 0. But remember, the shortcut, all you need to do is set the numerator equal to 0. So to get my x-intercepts to x minus 1 equals 0, what I did was I plugged in a 0 for y and simplified it down. And this is what resulted. So now I solve for x, divide by 2, and x equals 1/2. So my x-intercept is the order pair 1/2, comma 0. Now I need to find my y-intercept? I find that by plugging in 0 for x. So y equals 2 times 0 minus 1 over 0, negative 1 over 0. This simplifies to undefined. Because this is the undefined, there is no y-intercept. Now let's graph the asymptotes, and I'll graph the x-intercept. Then I'll look for additional points. So again, let me make my coordinate plane, and then I'll make my table of values. So I have my horizontal asymptote at y equals 2. So it's this horizontal line. Let me do it with highlight. It's the horizontal line through positive 2. It's the equation y equals 2. My vertical asymptote is at x equals 0, which is actually the y-axis. And now I can graph my x-intercept. Remember, I don't have any y-intercept. So I'm going to graph the ordered pair 1/2, comma 0. I need to get some additional points. I need some points that are less than the blue line, so I could plug in negative 1. So let me do a table here. And g of x equals 2x minus 1 over x. So when I plug in negative 1, I get negative 2 minus 1 over negative 1, which is negative 3 over negative 1. Negative divided by negative becomes positive 3. So the ordered pair I'm going to graph is negative 1, comma 3. So I could go ahead and put that on my graph. Right here. Now again, if you already know that the graph now needs to be in that little section, you can just draw the boomerang, make it follow along the asymptotes. If you're uncertain, plug in some more numbers. But I don't need to see an exact, I just need to shape, you know, it's going to take on a curve there, and it's up there in that part. Now I already know my next graph, part of the graph is going to be down there where the x-intercept is. But let me just plug in 1 to get another point here. So 2 times 1 minus 1 over 1. 2 minus 1 is 1. 1 over 1 is 1. So the next order pair I'm going to graph is the order pair 1, 1. So I'm going to graph this one, and then this one's going to be right here. And again, you could make it skim along those asymptotes. So it's going to come and skim along the green line and the blue line. The domain here is going to be all real numbers except where that blue line is, and that's x equals 0. So domain, written in words, would be all real numbers except when x equals 0. Written in interval notation, negative infinity to 0, union with 0 to infinity. Example 3. So what we need to do is first see if we can simplify anything. I can't just cancel out random x's because, again, remember this is attached here. So let's go ahead and look for our asymptotes. So the first one I'm going to look for is the horizontal. Again, remember the horizontal looks at the degrees. So the top degree is 1. The bottom degree is 2. When the top is smaller, we automatically know the horizontal asymptote is y equals 0. You memorize this fact. So again, I'm going to graph this in green. Now let me look for the vertical asymptote. The vertical asymptote is found by setting the denominator equal to 0. So x squared minus x minus 2 equals 0. I need to find the zeros, so I need to factor this. So the factors of negative 2 that give me negative 1 are x minus 2 and x plus 1. Set each of the factors equal to 0. Solve for x on each. So I'll add 2. X equals positive 2. X equals negative 1. This graph has two vertical asymptotes. So one at positive 2 and one at negative 1. Now let's find the x and the y-intercepts. So let me find my x-intercept. Again, remember you're plugging in y equals 0, but bottom line, all you need to do is set the numerator equal to 0. So x equals 0. So my x-intercept is located at 0, 0, because remember the y value is always 0. For the y-intercept, we're setting x equal to 0. 0 squared minus 0 minus 2. 0 divided by anything is just 0. So my y-intercept is also 0, 0. This is going to be the scenario where my graph is actually going to cross the horizontal asymptote. It will never cross a vertical asymptote, but it may cross a horizontal, and it does on this problem. So let's go ahead and get these pieces of information on my graph, and then we're going to look for additional points. So I'll go ahead and make my coordinate plane. I'm going to do it down here in the white part. So I had a horizontal asymptote at y equals 0. So it's the x-axis here. And then I had two vertical asymptotes. One was located at negative 1, and one was located at positive 2. So I have one here at x equals negative 1, and another one at x equals 2. So now what I need to do here is I need to find what's happening in each one of these sections. I'm actually going to have something that's graphed in here, in the middle, and to the left. Now, when I graph it on the far left and the far right, that's going to be the boomerang shape. But in the middle, it's going to take on the shape of the x cubed graph or the negative x cubed graph. All right, so let's go ahead and get some additional points. Yes. Yes. Okay. So let's go ahead and also graph. I can graph my x and y intercept, which is the order pair right here in the middle. All right, so let's do a table of values. So I'm going to pick points that are less than negative 1. So I'm going to plug in negative 2. If you'd rather plug in negative 3 or negative 4, that's fine. Just something that's less than that first vertical asymptote. So g of x equals x over x squared minus x minus 2. That's where I'm plugging negative 2 into. Be very careful with your negative signs here. See how when I plug it in here, the negative negative, this is actually going to turn into a plus 2. So negative 2 squared is 4. Negative negative becomes plus 2 minus 2, which simplifies into negative 2 over 4, which is negative 1/2. So the order pair I'm graphing is negative 2, comma, negative 1/2. let me also, so over here, I can plot this point, -2, -1/2 is right here. And again, you're using your asymptotes as a guide, and again, it's like a boomerang shape. So that's that piece. Now I have to find what's happening there in the middle. So I'm going to plug in +1. So over here on my table, 1/(1)² -1 -2. 1 -1 -2, and this one also gives me -1/2 when I plug it in. So that order pair is going to be 1, -1/2. So I can come over here. Now again, we're using the asymptotes as our guide. This one is actually crossing it. So it's going to come over here, and it's taking on the shape of this -x³ graph. Now, in order to see that it goes and curves up like that, if we were using our graphing calculator, we would use the table and we would see additional order pairs. So if you weren't sure how to connect these dots or to make the wiggle in the middle, I would plug in like maybe -1/2 or -3/4 to see what it was doing. But if we were in the classroom, this is where our graphing calculator would come into play, and we can get the additional order pairs. Now let's pick values for our table that are greater than 2 to get the far right part of the graph. So I'm going to plug in +3, and I get 3/9 -3 -2. 3/6 -2, which gives me 3/4. So 3, 3/4. Let me go ahead and graph that one. And it's going to be up above. So it's going to be probably around here. And again, using your asymptotes as the guide, that's how the graph will look. So again, this is where a graphing calculator will help you. Again, if we were doing this in the classroom, everyone would have a graphing calculator, and you would get your additional, you wouldn't have to be doing a table. You would get your additional points from your calculator. But because we're not, and it's not required, we have to do all these calculations by hand. So if you're not sure how your graph is wiggling or curving, you're going to plug in more points than what I've done. Let's try the next example. Oh, let's do domain. So this one's got 2 numbers that I have to exclude. So my domain here would be all real numbers except when x equals -1 and when x equals +2. That's where my blue lines are. These are my asymptotes. In interval notation, it would be from -∞ up to the -1, union, jump over that, start up again at -1 to +2, union with 2 to infinity. So this is the domain. Remember, we do not include the vertical asymptote values. So again, step 1, we should always try to simplify the rational function. I'm going to factor the numerator and factor the denominator. So g of x is equal to x plus 3, x minus 3. This is the difference of 2 squares. The denominator I can factor into x minus 3 times x plus 1. To simplify, I got to make a perfect match. I can cross off the x minus 3's, and the simplified function is g of x is equal to x plus 3 over x plus 1. This is the simplified function. Now, what's different about this one compared to the other three we've done, the factor that we canceled out, this is where our hole is going to be located. So I'm going to take the factor that I canceled, the x minus 3, I'm going to set it equal to 0. I'm going to add 3. So the hole is located when x equals 3, but to find the y value, you're going to take your simplified function and you're plugging in 3 for the x. So this will become 3 plus 3 over 3 plus 1, 6 over 4, which simplifies to 3 over 2. So the hole in my graph is going to be located at the order pair 3 comma 3 over 2, or you could say 3 comma 1.5. This is where I'm going to have a hole in the graph when I make my graph. Now I'm going to go back and find the horizontal asymptote and my vertical asymptotes. Now you could have gone ahead and done that at the beginning and then found the hole. It doesn't really matter, but if you're following the steps that were on that second slide, it said to simplify, find the holes, and now I'm going to find the asymptotes. So for my horizontal asymptote, we look at the degrees. The degree of the numerator is the same as the degree of the denominator. So we have same degrees. They're both to the second power. So this is where we're going to use coefficients. So y equals 1 over 1, which gives me a horizontal asymptote of y equals 1. So this is my horizontal, y equals 1. Now I'm going to do the vertical. Remember, for the vertical, you set the denominator equal to 0. Well, in order to do that, we would have needed to factor it. So here, actually, we're going to take the simplified fraction. So we're going to take x plus 1, set it equal to 0. And that was what was in the simplified function. So I have a vertical asymptote at x equals -1. Now I have to find my x-intercept and my y-intercepts. So for the x-intercepts, we're going to be plugging in and setting y equal to 0. So again, it's just setting the numerator equal to 0. Subtract 3. So I have an x-intercept at -3 comma 0. For the y-intercept, I'm plugging in x equals 0. So if I take my simplified function, 0 plus 3, 0 plus 1, 3 over 1. So my y-intercept is happening at 0 comma 3. Because I had set x equal to 0. So this is the y-intercept. This is my x. Let's go ahead and get all this information on the graph. So here's my coordinate plane. One, two, three, four. 1, 2, 3, 4. So let's graph the horizontal asymptote. Remember, it's a horizontal line through 1, because it's y equals 1. So that's my horizontal, y equal 1. My vertical is at x equals -1. So that's my vertical asymptote right here. That's the vertical. Next, I'm going to graph my x-intercept. It's at -3 comma 0. Then I'm going to graph my y-intercept. It's at 0,3. I'm going to make the hole in the graph. Let's make the hole in yellow. The hole is going to be at 1, 2, 3, and then 1.5. So here's the hole. So again, I've got enough information here, but I could quick do a table of values. I plugged in -2, and I got -1. And then I also plugged in 1, and I got 2. So let me just add these two order pairs. In the video, I'm going to do it in the table. So -2 and -1 is right here. So then I can make follow my asymptotes. And then over here, +1, +2. So your graph's going to come along here. It's going to come to the hole. It's going to skip the hole and keep going. So leave this as an open circle, and this is your hole. Let me go ahead and quick show you the work to get those two order pairs that I just created. So again, doing a table of values. If you go ahead and take your function and you plug it in to the simplified, g of x is equal to x plus 3 over x plus 1, -2, -2 plus 3, -2 plus 1. This gives me 1 over -1, which gives me -1. If I plug in +1, 1 plus 3, 1 plus 2, 4 over 2, which gives me 2. So that's how I can get those two additional order pairs for this graph. The domain for this function is going to be all real numbers except when x equals -1. In interval notation, this is going to go ahead and be from -infinity up to -1, union with -1 to infinity. Now, anytime you want to do other points, you don't have to come up with the exact same ones that I did. Again, if you were using a graphing utility, you could get other additional points. If you'd rather plug in like a fraction, you could plug in -0.5. I could have plugged in +4. Any other point that you wanted to graph, you can also do that. So let's go ahead and try next one. So this is going to be our first example where we actually have a slant asymptote. So again, first thing, I need to try to see if I could simplify anything here. So if I try to factor the numerator, it'll factor into x times x minus 1, but nothing simplifies here, so it didn't help me. So let me go and find my horizontal asymptote. Remember, we look at the degrees. So this time, the degree of my numerator is 2. The degree of my denominator is 1. So when the top is 1 bigger, then you have a slant asymptote. Because when the top is bigger, there is no horizontal asymptote. So the top is a bigger degree, so there's no horizontal asymptote. But when that numerator has 1 degree larger, then we actually have a slant asymptote. And to calculate what that slant asymptote equation is, we're going to be doing long division. So I'm going to take my original function. The numerator goes in the division box, and the denominator goes outside. So I'm going to go ahead and start my long division. What do I need to multiply x by to make it x squared? I'm going to multiply it by x. So x times x gives me x squared. X times 1 just gives me x. I switch the signs to opposite. That's gone. And now this leaves me with negative 2x. What do I need to multiply x by to make it negative 2x? I'm going to multiply it by negative 2. Now I could add in the plus 0. I would bring down just to show how it lines up. Flip the signs. I don't care about doing anything with the remainder. I only want this part of the long division. And my equation for my slant asymptote is y equals x minus 2. You might also see this referred to as an oblique asymptote, but just know this is our slant asymptote. So now let's go back. So we don't have a horizontal, we've got a slant, and we also have a vertical asymptote. So let's go ahead and calculate that. So for the vertical asymptote, remember you set the denominator equal to 0. Subtract 1, and x equals negative 1. So I have a vertical asymptote at x equals negative 1. So this is my vertical. Remember, horizontal, you'll say that there is none, but then you're also going to describe that we have a slant asymptote for this question. Let's also go now and calculate the x and the y-intercepts. So for the x-intercepts, or finding the zeros, we're setting the numerator equal to 0. I'm going to factor it. So I have x-intercept when x equals 0, and then another one at positive 1. So again, we'll turn these into coordinates. So we have one at 0, 0, and at 1, 0. For the y-intercept, we're going to plug in x equals 0. So back at my original, 0 squared minus 0 over 0 plus 1. 0 over 1, anything divided by 0, 0 divided by anything is 0. So my y-intercept is 0, 0. So let's go ahead and get all of this information on my graph. And then I'm also going to look for additional points to plot. So let me go ahead and make my coordinate plane here, my x and my y axis. Let me add in my horizontal asymptote, which is none. So I'm going to graph my my slant asymptote in yellow. Actually, let me go ahead and graph it in black so it shows up better, and I'll highlight it in yellow. So the slant asymptote, remember, is the equation y equals x minus 2. So I'm just going to graph using my y equals mx plus b technique. My first point, I'm going to start, my beginning point is at negative 2, and then my slope is 1, so I'm going to rise 1, run 1. So I'll put my first point here, rise 1, run 1, and I can keep going and keep repeating the process. So this is my slant asymptote. And again, I can go over it in yellow. So this is the slant asymptote. Let me add in the vertical asymptote, which I'll do in blue, which is the equation x equals negative 1. So over here, I'll highlight my vertical asymptote in blue. X equals negative 1 is the vertical. Let me go ahead and add in my intercepts. I have one at 0, 0. I've got another one at 1, 0. So now I need to go ahead and get some additional points on my graph, because this could actually keep going down. And I could even extend my asymptote here and this one down. Oops, let me do it in highlight. All right, so let's do a table of values to see where our graph is located. So x squared minus x over x plus 1. Nothing simplified here. So let me pick a number that's less than negative 1. So let me plug in negative 2. And then when I plug in negative 2 and square it, minus negative 2. for plus 2 over negative 1, 6 over negative 1, which gives me negative 6. So negative 2, negative 6. If you want to see another one that's over there, just so you can see that we do have an additional piece of graph, it's going to be down here in this section here. Let's go ahead and get the official order pair. So negative 4 squared minus negative 4 over negative 4 plus 1. So 16 plus 4 over negative 3, 20 over negative 3, which will be negative 6 and 2/3. So let's graph these. So I'm going to graph negative 4 and negative 6 and 2/3. So if I come over here, let me add in some marks, 2, 3, 4. So negative 4, and then 3, 4, 5, 6. So it's going to be like right in here, maybe a little bit lower. And then I also have the order pair negative 2, negative 6. So then it's going to be skimming along these asymptotes in this section. Now let me pick a number over here. I already have some, but let me go ahead and plug in positive 2 just to get another point over here. So if I plug in 2, 2 squared minus 2 over 2 plus 1, 4 minus 2 over 3, 2 over 3, so 2 comma 2/3 will be another point. So 2 and then 2/3 is about here. So my graph over here is actually going to come along, skim. Let me make it hit that x-axis, and then it's going to skim over here. So this would be this graph, this rational function. The domain in words would be all real numbers except when x equals negative 1. And then we also have from negative infinity to negative 1 unioned with negative 1 to infinity. And that would be the interval notation for that domain. Let's try another one. This one also has a slant asymptote because we can already see that the degree on the top is going to be the bigger degree, and it's 1 bigger. So let me go ahead and see if anything will simplify here, if it helps me. This will factor into x minus 2, x plus 1. And the denominator will factor into x minus 1. Nothing cancels, I can't simplify, so this graph doesn't have any holes. So back to checking out the degrees. So for the horizontal asymptote, you check the degrees. So the top is 1 bigger. So obviously, since the top is bigger, there's no horizontal asymptote, but because the top is 1 bigger, it's got a slant asymptote. And to find that, I need to do long division. What am I going to multiply x by to make it x squared? I'm going to multiply it by x. So x times x is x squared minus x. Flip the signs. And then this ends up being all zeros here. Even if I bring this down, I don't care about the remainder. So my slant asymptote is y equals x. Let me go ahead and get my x-intercepts. I can use the numerator, set it equal to 0, factor it, set each of the factors equal to 0, x minus 2 equals 0, x plus 1 equals 0, add 2, subtract 1. So I've got an x-intercept located at 2, 0 and negative 1, 0. Let's do the y-intercept. We're plugging in 0 for x. So 0 squared minus 0 minus 2 over 0 minus 1. This gives me negative 2 over negative 1, which gives me positive 2. So my y-intercept is the order pair 0, 2. So let's go ahead and get all of this information on my coordinate plane. So I can graph my x-intercepts, my y-intercept. Let me come back up here, get my horizontal asymptote, which I don't have. Remember, it was none. My vertical asymptote is going to be, did I do that? I did not do that. Let me add that one in. So the vertical asymptote, set the denominator equal to 0. I have one at x equals positive 1. So there's the vertical. And now my slant asymptote is just this equation of y equals x. So start at 0, 0. Rise 1, run 1. So here is my slant asymptote. And let me go ahead and highlight that over in yellow. So that's the slant. So now what we need to do is figure out where our graph is going to go. So really, as long as you know it's a boomerang, we do have enough information on here. But let's go ahead and do a table. Let's add a couple more points on here. So I can take x squared minus x minus 2 over x minus 1. I'm going to plug in negative 2. Negative 2 squared minus negative 2 minus 2. Negative 2 minus 1. 4 plus 2 minus 2 over negative 3. This gives me 4 over negative 3, which is actually going to be negative 2, and this becomes negative 1.3 repeating. And now let me plug in positive 2. And again, you're choosing whatever you want for your x values to plug in. So 2 squared minus 2 minus 2. And then 2 minus 1. 4 minus 2 minus 2 over 1. And this ends up giving me 0 over 1, which is just 0. So 2 comma 0. And over here, let's plug in 3. 3 squared minus 3 minus 2 over 3 minus 1. 9 minus 3 minus 2 over 2. 6 minus 2 over 2. 4 over 2, which is 2. So that order pair is 3 comma 2. So let's go ahead and get these points all on our graph. Actually, I already graphed this one. Graph this one and this one. So negative 2 and negative 1.3 probably down here. So again, you can see how it's skimming along your asymptote. And then over here, if I graph 3 and positive 2, it's going to be like here. And again, it's going to skim along. So that's number 6. Domain, let's go ahead and do that. So the domain is all real numbers. Okay, all real numbers except when x equals positive 1. And in interval notation, negative infinity to 1, union 1 to infinity. One last example. And we have g of x is equal to 3x squared plus 1 over x. So again, nothing can be simplified. So let's go ahead and find our horizontal. So the top is bigger. So this tells me that I have no horizontal asymptote. I actually have a slant because it's 1 bigger. So 3x squared plus 1 divided by x. What are we going to multiply x by to make it 3x squared? I'm going to multiply it by 3x. And then here, I should have held the space with this. And subtract 0. I don't need to worry about the remainder. So my equation for my slant asymptote is y equals 3x. For my vertical asymptote, remember you set the denominator equal to 0. So I'm done. So there's your vertical. Remember horizontal is none. And then slant is y equals 3x. Let's find the x-intercept. 3x squared plus 1 equals 0. Subtract. Divide by 3. X squared. When I go to square root this, it's going to be an imaginary, so there is no x-intercepts. So we don't want an imaginary. We only want real. For the y-intercept, we're setting x equal to 0. So 3 times 0 squared plus 1 over 0. Anything divided by 0 is undefined. So this also has no y-intercepts. So let's go ahead and put the two asymptotes on our graph, and then we'll plug in some points to see where the graph is located. So I've got my vertical asymptote. It's located at x equals 0. So I'm just going to highlight because it's just the y-axis. And then I need to graph the slant asymptote. So I'm going to start at 0, 0, and I'm going to rise 3 and run 1. Rise 3, 1, 2, 3, and then I can run 1. So I can go ahead and create my slant asymptote. Actually, let me do this in black. I'll connect the point for the slant, and then I'm going to highlight it in yellow. This is the slant asymptote. And again, it's the equation y equals 3x. So now let's do a table so we can see where our graph is going to be located. So let me plug in -1. And again, 3x squared plus 1 over x. 3 times -1 squared plus 1 over -1. 3 plus 1 over -1. And this is going to give me 4 over -1, which is -4. So -1, -4. And then let me plug in +1. 3 times 1 squared plus 1 over 1, which gives me 4 over 1, which gives me +4. So 1, 4. So let me graph these 2 points. So this is going to tell me where on my graph here in between these asymptotes my graph will occur. So +1, +4, it's right here. So I know my graph is going to be squeezed in between here. And then -1, -4 will be about here. And that's where that piece will be. So my domain here is going to be all real numbers. So all real. Let's see if I can erase this. So all real numbers except x equals 0. So -infinity to 0, union 0 to infinity. And I'm done. So that is graphing rational functions. So again, your homework is not on WebAssign, it's a PDF. That's it.